This is the last video in the installment of adding, subtracting rational expressions. This particular video is going to deal with, unlike denominators that are mainly binomials and trinomials. Again, monomials were a previous video. So from the last video, if you recall, I talked about you need, again, common denominators. And when I have binomials and trinomials, the first thing that you need to do is to factor denominator fully. Okay, what I mean by that again is taking each denominator and factoring it to its smallest parts, right? So factoring it as much as you can, simplifying it. So if I look up here with the b minus 3, okay, that's one denominator. I can't do anything with that. I can't take a number out because b minus 3 is its factored form. That's the smallest factor it could be. So that is b minus 3. So that's going to stay the same. If I look now, the 5b to the third minus 30b squared, that is going to need to be factored. That looks as though it can be, right? So how can it be factored? Well, they both, the 5 and the 30 can both be pulled out as a 5. Then I have b to the third and b squared. Well, what's the smallest they have in them? Well, that's b squared, right? Times what's left? b minus 6. So now if I look at it, how the heck do I find common denominators between 5b squared times b minus 6 and then b minus 3? So here's how I do it. I am going to take the first fraction, I'm just going to write it, okay, differently, just with 5b squared times b minus 6 there. My second fraction we know is 6 over b minus 3 because that b minus 3 is fully factored. So I need a common denominator. If I look, this is a monomial. Okay, 5b squared is a monomial. That's the only monomial I have in my denominator. I do not have a monomial here at all in the b minus 3. So I know, so here's some kind of shortcuts and kind of things to do. Because I only have one monomial, that monomial has to be in my denominator. It has to be. Because I don't have another one to kind of cancel out or kind of simplify with. Now, if I look with my binomials, b minus 6 and b minus 3, are they the same? No. Because they're not the same, I need both of them in my denominator as well. So my denominator is going to be 5b squared times b minus 6 times b minus 3. Now I need to find my numerator to reflect that, right? So how did I go from that denominator, 5b squared times b minus 6, to my new denominator with a b minus 3 into it? If I looked, all you did was multiply by a b minus 3. That's the only change. So I have to multiply by b minus 3. When I do that, I get 4b minus 12. Now my second denominator. How did I go from b minus 3 to all of that? Well, I multiplied by 5b squared and a b minus 6. Now what do I do? Well, now we got to multiply the top as well by the same thing that I multiplied the bottom with. So times 5b squared times b minus 6. So what does that give me? That gives me 30b squared, 6 times 5 is 30, times b minus 6, but is actually 30b to the third minus 180b squared. How did I get that? I distributed. So now what do I actually get? I get 4b minus 12 over, remember it's 5b squared, b minus 6, and then b minus 3, minus my numerator from the second fraction, which is 30b to the third minus 180b squared, now divided by, again, my same denominator, 5b squared times b minus 6, b minus 3. Now I can combine like terms and subtract and do all that stuff. So let's do that. So I get 4b minus 12. This negative is being distributed minus 30b to the third plus 180b squared over 5b squared times b minus 6 times b minus 3. Well, again, I'm not done yet. These problems are a lot of work. Combine like terms in the numerator. If you look, nothing can be combined because I have b to the third, b squared is a b, and a 12. Nothing can go together. So now what do I have to do? Well, let's pull out numbers that they have in common. All of them can be divided by 2. So let's pull out a 2. Times 2b minus 6 minus 15b to the third plus 90b squared over 5b squared times b minus 6 and b minus 3. And because my monomial in the denominator and my monomial in the numerator cannot be simplified, that is my final answer. You can rewrite it different ways, but that is your final answer. Let's look at this particular problem. Again, my denominators are not the same. That's a 2, and this is a trinomial. But let's look at it again. If I look, I have a 2, a 16, and a 24. What does that mean? That means I can divide them all by 2. So that's the first thing you need to do. Again, we talked about factoring fully. We need to take out, remember, talk about greatest common factor, take them out if we can. Now, the x squared minus 8x plus 12, I can make a box, or make an x anyway. 12 on top, negative 8. That's negative 6 and negative 2. So it's 2 times, remember it's x minus 6 and x minus 2. So now I can rewrite my fraction. I get 6x over 2 times x minus 6, x minus 2, plus 3 over 2. I need a common denominator, okay? So let me stack these a little bit. So let's look at them. Well, I have a monomial, binomial, and a binomial, and here I have a monomial. So if I look at my monomials, 2 and 2, what's the smallest monomial that they can both go into? Well, they can both go into 2. Because I have a binomial x minus 6 up on top, but there isn't one here on the bottom, that means that x minus 6 also has to be in my denominator. Well, also the same thing with x plus 2. I have one up top, but I don't have one here, so that means it also has to be in my denominator. So my common denominator is going to be 2 times x minus 6 times x minus 2. Now I need to multiply my numerators to reflect what I did to the bottom. How do I do that? Okay, here is how. My first denominator here to my new denominator, as you'll notice, they're both the same. So that means I didn't change. I didn't change anything. I didn't multiply by anything, so that means the 6x is going to stay the same. What did I do from the 2 to get to 2 times x minus 6 times x minus 2? Well, I multiplied by x minus 6, x minus 2. So that means I have to multiply by the top. So I get 3 times x minus 6, x minus 2. Now let's start adding and subtracting and multiplying and doing all that other stuff. So here we go. I get 6x over 2 times x minus 6, x minus 2, plus 3 times x minus 6, x minus 2, over 2 times x minus 6, x minus 2. We know that when I add them, my denominator is going to be 2 times x minus 6, x minus 2. That's easy. But my numerator is going to change. What do you mean? I have to make a box with x minus 6 and x minus 2. Or you do that in your head if you can. That's x squared minus 8x plus 12 being multiplied by that 3. So that's really 3x squared minus 24x plus 36. That's being added to the 6x prior. So remember, this is a plus, it's being distributed, plus 3x squared minus 24x plus 36. Combine like terms. 3x squared minus 18x plus 36 over 2 times x minus 6, x minus 2. Now I need to see if this can become smaller and maybe cancel out with the denominator. Okay, so what does the numerator have in common? It has a 3, but all of them can be divisible by 3, so I'm left with x squared minus 6x plus 12 over 2 times x minus 6, x minus 2. What I need to do with this trinomial here is to try to factor using an x. So I get 12 and negative 6. If you try to do the math, there are no numbers that are going to be the magic numbers that make positive 12 but add to a negative 6. That means that trinomial, x squared minus 6x plus 12, cannot be factored. Because it can't be factored, it cannot be made into binomials. Therefore, I am done, because the only thing that potentially could be factored is the 3/2 out front, but 3/2 cannot be simplified any further. So monomials can't be simplified, that trinomial cannot be simplified, and my binomials in the denominator cannot be simplified with anything. So my answer is that in the box. Go ahead and pause the video to try to figure this one out, and then hit play to see if you are right or if you needed additional help. My denominators, you'll notice, are not the same. We need to factor as much as we can. We know that that is already factored. Then if I look at 3x minus 4, that's already factored as well, meaning I can't make it smaller. That's the smallest it could go because 3 cannot go into 4. So my fractions are 4x over 3x minus 4 minus 4x over x minus 1. I can't do anything with it, but I do need common denominators. So I have 4x over 3x minus 4 and then 4x over x minus 1. I need common denominators. You'll notice that both of these are binomials. Are they the same? No. So that means we need both of them in my denominator. So now how did I multiply from this one to get to this one? I multiplied by 3x minus 4. And then from here to here, I multiplied by x minus 1. So 4x times then the x minus 1 will give me 4x squared minus 4x. Once I distribute that through, that's the reason why I get 4x squared minus 4x. Then on the bottom, I got to multiply 4x by that 3x minus 4. Again, I distribute. That gives me 12x squared minus 16x. So then now coming back to the original problem, I get 4x squared minus 4x over what my new common denominator was 3x minus 4 times x minus 1 minus my new numerator on the right side over my new denominator, that's the common one. So then I know my answer is going to have the common denominator again in the bottom. So 3x minus 4 over x minus 1, or times x minus 1. And then up top, I get 4x squared minus 4x. But then this negative gets distributed, so it's minus 12x squared plus 16x. So what can I do? Well, I can combine like terms. So I get negative 8x squared plus 12x over 3x minus 4 times x minus 1. Well, I'm not done yet. Okay, what can I do? If I look up top, I can pull out a negative 4x from both terms. When I pull out a negative 4x, I'm left with 2x minus 3 over 3x minus 4, x minus 1. And because my binomials are not the exact same thing in my numerator or denominator, and I have no monomial to cancel with the negative 4x, this is my final answer for this particular problem. Go ahead and pause the video to try to do this one, and then press play once you get done, or if you need additional help, then continue watching. So I need to make sure I have common denominators. So again, I need to factor fully. That n plus 1 can no longer be factored, like it's in its factored form. So n plus 1 we know has to remain there. This here, the 3n plus 3, if we think about it, both of them have a 3 in there. What am I left with? A 3n plus 1. So I have the 6n over the 3 times n plus 1, and then the 3 over the n plus 1. I need a common denominator. What is it? If I look at the top, the first fraction, my denominator right there, I notice I have a monomial and a binomial. That monomial, I do not have another monomial here, so that means that monomial has to be in both of them. That has to be in my common denominator. Now I look at my binomial. Both of them are the exact same thing. That means that all I need is just one more of them, the n plus 1 there. They both contain the n plus 1, so I need it in my common denominator. Now going from this 3 times n plus 1 to my new denominator, you'll notice that I didn't multiply by anything, so this 6n actually stays the same. From this n plus 1 to that new denominator, that's 3 times n plus 1, you'll notice that I multiplied by 3, so I have to multiply that 3 by 3 to get 9. So now my new problem is 6n over 3 times n plus 1 plus the 9 over 3 times n plus 1. So now let's keep going. What happens? Well, I know my denominator is going to be 3 times n plus 1 because it has to be. And then my numerator is going to be 6n plus 9. But this 6n plus 9 can be factored. I can divide both of them by 3. So I get 3 times 2n plus 3 over 3 times n plus 1. So now I have monomial, binomial, monomial, binomial. My monomials, you notice, are divisible by 3. So they can cancel out. They become 1 when they do that. My binomials are not the exact same thing, so my answer is going to be 2n plus 3 over n plus 1. And that is my final answer because none of it can be simplified. This concludes this video that is adding and subtracting rational expressions, and this video was mainly dealing with unlike denominators that were binomials and trinomials. If you need help with previous material, please look for those videos.